Hello students, welcome to my channel. So in the previous lectures we have seen that how to measure very small lengths, for example diameter of a molecule, and we took the example of oleic acid molecule. We also learned how to measure the big distances, for example the distance of moon from earth. So this means that there is a big range of lengths, big range of distances which we measure, and accordingly we have different units for length. Special units for length, though they are in meters only, but how do we define those big lengths? And then the range is so big that then we have very small lengths also, diameter of an atom or a molecule. Keeping in mind those big range of lengths, we have these special units. 1 Fermi, for example, 1 Fermi. So when we have a length so small, which is 10 raised to the power minus 15 meters, so we better call it 1 Fermi. Similarly, we have 1 angstrom. 1 angstrom. So when we have length so small, 10 raised to the power minus 10 meters, instead of saying it 10 raised to the power minus 10 meters, we just simply call it as 1 angstrom. Then we have 1 astronomical unit. 1 astronomical unit, which is equal to 1 AU. 1 astronomical unit is that average distance of sun from earth. Average distance of sun from our earth is 1.496 into 10 raised to the power 11 meters. So this is equivalent to 1 astronomical unit. So instead of saying the distance of sun from our earth is this much, we just say that it is 1 AU. Then we have 1 light year. 1 light year is the distance which light travels in 1 year. So as you know that light speed is 3 into 10 to the power 8 meters per second, right? So it travels 3 into 10 to the power 8 meters in 1 second. So how much distance this light will travel in 1 year? That is called light year. So this speed in 1 year. So this is 1 light year. So these are some of the special units which we use when we are measuring very small distances or when we are measuring very big distances.